So now we're going to look at some other probabilities of independent events. And again, independent events means that the first event does not affect the second event. So you'll notice in the wording of these problems, these will be indicated as independent. So there are 3 red marbles in a bag, 2 green and 1 blue. Find each of the following. The probability of getting a red and then a green if you put the red back in the bag before choosing the green. So what are the key words here that let you know that this is independent event? Put the red back in the bag. If I had left the red marble out, then there'd be a change in my outcomes for choosing that second marble. That's called dependent events, which we'll talk about later. But because we put the red marble back, we always start with the same probability of everything for each time we calculate a probability. So here we're figuring out the probability of getting a red and then a green. So we're going to do probability of red times probability of green. So what's the probability of red? Probability of red is 3 out of 6, right? You can simplify that or not, it doesn't matter. Probability of green, 2 out of 6. You can simplify at first or you can cross cancel at this point. Either way, it doesn't matter. So we end up with 1/6 is the probability of getting a red and then a green. Here we have the same example but a different question. Find the probability of getting a blue and then a green if you put the blue back in the bag before choosing the green. Again, it's important to note that this is independent because it says if you put the blue back in the bag. We're not keeping it out. So we're going to find the probability of a blue and then a green. So that's the same as the probability of a blue times the probability of a green. So the probability of the blue would be what? 1 out of 6 times the probability of a green, 2/6. So what's your probability of getting a blue than a green? Well, we can cross cancel here. Love that cross canceling. 1/18. Try this problem. I got 1/9. Try these 2 problems, but stop on the third. Let's do the third together. So here I ended up with 1/4 for both. Let's look at the next problem. This one's much trickier. The probability that exactly one head shows. Okay, so we're flipping 2 coins and we want the probability that exactly one head shows. That could be heads and then tails, or that could be tails and then heads for exactly one head to show. So what we're going to do is we're going to break this down into pieces. We're going to find the probability of heads and tails plus the probability of tails and heads. So the probability of heads and tails would be the probability of heads times the probability of tails, and then we're going to add that to the probability of tails times the probability of heads. So the probability of heads is what? 1/2, right? What about tails? 1/2 as well. What about tails? 1/2, and heads? 1/2. Now you want to remember your order of operations. So are we going to multiply or add first? If it helps you, you can always do this, but you don't need to because you always multiply before you add. So it's 1/4 plus 1/4. I recommend that your fractions will get more complicated. I recommend you not simplifying them in the middle of the work to help you go ahead and have common denominators. It's less work to get your common denominators if you're not simplifying. So you get 2/4, which equals 1/2. Again, try these first 2 problems and then stop. We'll do 3 and 4 together. For number 1, I have 9/25. For number 2, I have 4/25. Now let's look at 3 and 4. So for number 3, it says the probability that both are the same color. So we need to break down what that means. That means the probability of orange and orange and the probability of blue and blue. So either one of those. So we're going to do the probability of orange. Well, actually, we've already done it, right? So we already figured out for number 1, the probability of orange and orange is 9/25. And for number 2, the probability of blue and blue is 4/25. You add those together, what do you get? 13/25. So the next one, the probability both are different colors. So that's a little bit trickier. Not a lot, but a little bit. So we want the probability of orange and blue and the probability of blue and orange. So we have for orange it was 3/5 was the probability. For blue it was 2/5 plus 2/5 times 3/5. Again, if it helps, you can put parentheses to remind yourself to multiply before adding, but you don't have to. So we get 6/25 plus 6/25, which equals 12/25. Finish this last page and then check your answers. Here are my answers. Number 1 is 1/16. Number 2 is 2/16, which equals 1/8. Number 3 is 4/16, which equals 1/4. And number 4 is 1/2.